Welcome to the KuppingerCole Analyst Chat. I'm your host. My name is Matthias Reinwarth. I'm an analyst and advisor at KuppingerCole Analysts. In each edition, I have one guest joining me, often a fellow analyst or another interesting partner, and we have a 15 minutes chat around an interesting topic. My guest today, and I'm very happy to have him here again, is Alexei Balaganski. Hi, Alexei.
Hello, Matthias.
Great to have you here. Usually I have you when it comes to security topics and cybersecurity. Today we are talking about something a bit different. Our topic today is enterprise databases in the cloud. And as we are both already for quite some time in the market, and I think back, say, some 25 years or so, then enterprise databases were products that were relational databases. They were expensive. They were maintained on-premises, of course, and there were names like Informix, Sybase, Oracle. What has changed since then? What are enterprise databases in the cloud like today?
Well, you're right. You mentioned so many names, and some of them, of course, are no longer with us at all. Some still survive. Some are looking to reinvent themselves completely to kind of match the current completely changed expectations from businesses. But I guess the biggest problem is that in the very phrase enterprise database in the cloud, everything is new. The enterprises have changed. The very notion of database has changed completely. And of course, we have the cloud with a totally different, if not very new anymore, but still a completely different way to store or to manage to process your data. And the biggest challenge, I guess, is that we are living in a world so different from what it used to be 25 years ago. That old school monolithic relational database management system just is no longer relevant. And again, some companies have not survived this change. They are no longer on the market. The others still are and doing quite well. And we'll probably be talking about specific names later. But the point is that from the customer perspective, from the enterprise perspective, the database is no longer just a specific product for storing a specific, well, kind of rigidly defined relational data. A database nowadays can mean a lot of things. We now have NoSQL databases, we have graph databases, we have document databases, we have time series databases, real-time data stores for IoT purposes, we have data warehouses and other big data frameworks, we have data lakes, you name it. And from the technology expert's perspective, those are two completely different and often completely unrelated solutions. However, from the business perspective, this is still a database. And for any sufficiently large and sufficiently modern project, be it a new application or just migration of a legacy system to the cloud, it will almost surely never rely on a single type of database solution anymore. So you will never be able to just build your modern application infrastructure, let's say, only on a relational database or only on a specific type of database solution. This is why we are currently planning and currently working on our leadership compass for this topic. And we will be looking from a completely different, less technological, more business relevant perspective on these solutions.
Does that mean that you choose a database based on the actual problem that you want to solve or on the type of data that you want to store?
Yes and no. You now have so many different choices of a potential database to implement in your product, or even more than one database, that it became much more strategically important, I would even say critical, for the success of your long-term project to do the right choice in the beginning. Because one of the major problems of any data management solution in the cloud is a potential vendor lock-in. If you make a mistake, if you choose a solution which somehow limits your scalability or doesn't give you a specific functionality you need, and you know that a different database will work for you, but you have already invested so much in proprietary protocols or interfaces that you just cannot go back. without undoing all that long-term development. And in order to avoid these costly mistakes, you really have to approach the choice of your potential database much more strategically nowadays.
Okay, I've learned earlier that a typical reason for vendor lock-in are stored procedures, so that you have code within databases, which is not portable at all, while everything else from the data model could be portable. Is something like that still around?
I would say yes, but this is not kind of the level of challenges we are talking about, because even if you have the same database engine on premise, but you can migrate to the same database in the cloud, then you are fine, because you will just take your existing code and procedures and so on and lift and shift it to the cloud, and you are fine. So in that regard, when we are talking about proprietary interfaces, we aren't talking about proprietary, let's say, SQL extensions. I mean, they are, of course, still a challenge. And if you want to migrate, let's say, from Oracle to Microsoft SQL Server, yeah, that's still a problem for your developers. But if you want to migrate from, let's say, Azure Cloud to Oracle Cloud, it's a totally different level of challenge, if you will. You might still run Oracle in Azure Cloud or in Amazon Cloud. In that regard, you are not limited to a proprietary interface, because it will be still the same Oracle interface, regardless of the cloud. However, if, for example, you want to migrate to the whole range of database services offered natively by a specific cloud provider, then you are facing a totally different challenge. For example, we know that in Azure Cloud, you basically have a choice of quote-unquote standard databases, which are running on-prem just like as fine. And of course, you have a number of specifically designed cloud-native database interfaces. If you are looking at AWS, for example, then most of those database services would be cloud-native, supporting their own proprietary interfaces. If I am not mistaken, currently you have a choice of over 15 database engines from the AWS cloud. Do you want your developers to learn 15 new database interfaces instead of one, even if that one is a really old school and proprietary? That's a tough choice to make.
But if I think about the recent press, say 5 years back from now, and we look at the promises that graph databases came along with, that of course they talk SQL, they talk traditional interfaces, but they play out their strengths when it comes to using the actual paradigm that's behind that, the graph approach and the traversal of complex graphs. That often requires the developer to really change the way that they're thinking, don't they?
In a sense, you are looking toward in the right direction, if I may say so. Mm-hmm. So yes, the point is that when you are thinking about a migration project, if you have a legacy on-prem application on a legacy on-prem database, and you want to make something exciting and new and cloud native and massively scalable and geographically distributed and so on, of course, your old school database will no longer be physically capable to deliver that. Even if you just lift and shift your whole application infrastructure, including your database, to the cloud, which is perfectly fine for some scenarios, and it will still work fine. It will probably even work faster than on-prem and will be cheaper to operate. But it will be just that, lift and shift. It won't give you all those new fantastic capabilities of the cloud. But as soon as you are starting to evaluate those new fantastic capabilities, you have this, I would even say, almost religious kind of choice. Do you want to go for a large combination of best-of-breed individual services and quickly end up with an application infrastructure which requires 15 different databases? But it will be the fastest and the smoothest time series database. It will be the most secure and scalable blockchain. It will be the fastest and the cheapest data lake. But it will be a mess of a dozen of different application stacks and interfaces. Or do you want something which is, let's say, quote unquote, good enough, but which will give you a single set of interfaces, a set of tools which your developers are already knowledgeable with, And of course, it will give you the opportunity to query all your data from a single source instead of juggling, let's say, some data from a relational database with some graph data and some files from a data lake. And then you would have to run an additional level of abstraction just to make a query across those three sources. It's this fine balance for which there is no single right answer. It depends only on your project's requirements and time scale and budgets and skills and so many other factors.
Right. Some databases that I've seen in the cloud come with the promise of being multimodal, so that they are graph and they are relational, or at least they mimic this functionality and even more key value pairs and all this kind of stuff. Do they deliver on that promise?
Well, I guess some probably do. Some others maybe not yet. If you have a choice between like a large and established vendor like Oracle, for example, on one hand, and yes, their database is it promises to be multimodal and deliver that single querying capability across different data models, which at least on paper sounds extremely interesting to a developer. But of course, an Oracle database is still a monolithic piece of software. You cannot run it across, you cannot build a database which would kind of seamlessly span different cloud regions. And of course, if this is something that you're looking for, you would probably be looking for some cloud native solutions like NuoDB, for example, or if you are okay with NoSQL approach, like MongoDB. These are the features that were specifically designed for how to grow across multiple clouds, for example. And then again, you have to either learn a new set of interfaces, or you have to rely on those connectors, converters, or kind of emulation layers, because some of those modern databases come, for example, with like an Oracle emulation level.
Okay, got it. Maybe for the final minutes of this episode, let's shift the focus towards a feature that KuppingerCole is really always very much interested in. That's compliance, that's governance, that's security and data protection. The more organizations are moving critical data into enterprise databases in the cloud, the more they will require data protection, encryption, data hiding, all mechanisms that make sure that access to this information is really only granted to those who should have. How is the market here? Are they capable of protecting strongly this data in the cloud?
Well, this is, first of all, something which cannot be solved with one single approach. Actually, last year, we have released a leadership compass on specifically focusing on database and big data security solutions. And as we can see, there is also this agony of choice, if you will. You can rely on built-in security controls of a specific database, which of course have a massive advantage of being within the database core. So they are faster, more reliable, sometimes even more secure because they have access to the intimate internals of the database engine. On the other hand, those have a major flaw in that they are not vendor agnostic. So as soon as your project involves more than one database, either you have to install more than one database security solution, or you have to look for additional alternative approaches that, for example, focus on securing the information and not the database. And again, there are some really interesting aspects of that information-centric, data-centric security, which you could probably discuss in a separate episode. If there is one takeaway from this one with regards to database security, that database security in the cloud is not something which comes free with your cloud contract. So yes, the cloud provider will secure the infrastructure your database is running on. Sometimes they will even encrypt your data in the database. But it's still your own responsibility if something breaks, if the data is leaked. Because this is how the shared responsibility model for the cloud works. So if you store your data in an insecure S3 bucket on AWS and it leaks, you are responsible, not AWS, for example. the same applies to any kind of database in the cloud.
Okay. As we're getting to the end of this episode, what I've taken away is that people interested in more details around that topic should be carefully waiting for the Leadership Compass that's upcoming about enterprise databases in the cloud. In the meantime, they should pick up the Leadership Compass for data security that you just mentioned, database security and big data security. That was something that they should look into. And I know that you have already executed a set of webinars around that topic with various vendors, which they could also have a look at our site. Anything else that you would recommend where people can learn more than we could convey in just, say, 15 minutes?
Well, first of all, I have to add to the list you already mentioned that the data security in the cloud is impossible without securing the cloud itself. So I think we have quite a lot of research published on cloud provider selection and assurance, of what to look for in a specific cloud service provider when you are signing a contract with them. And of course, security and compliance is a huge aspect of that. And I'm sure that we have all those major providers covered in our research already. And of course, we are always open to specific questions, and we are ready to support you in any future project.
Okay, I think I will the latest invite you for that topic again when the Leadership Compass is published, so that we can dig into more details here. For the time being, thank you very much, Alexei, for being here with me again. Some final words from your side?
Well, thanks again for having me, so to say. Definitely looking forward to discuss some of these topics in more details, or of course, looking forward to do this in a more visual form, like a webinar or a physical event when this whole pandemic crisis is over. So stay safe, stay healthy, and looking forward to meeting all our attendees sometime in the future.
In real life. Okay, thank you very much, Alexei. Thanks to the audience for their time, and I hope that was valuable to them. Bye-bye.
Goodbye.